Hi guys, welcome to Stats Online. We are now in lesson 2-3, which we are looking at correlation in scatter plots. So today you're going to be able to estimate and interpret the correlation when we're looking at a scatter plot. And you should be able to match scatter plots with its given correlation. So we're going to start off with thinking about this idea of the key parts of describing a pattern that is in a scatter plot, so the correlation. And so what we've been looking at is we've been looking at the direction, if it's been negative or positive, if the data points or the pattern in our scatter plot, is it strong, is it weak, is it moderate, is there no correlation whatsoever, is it linear or not? And we're going to continue to build upon those. So let's first talk about correlation in terms of R. It is the measure between the strength and the direction, of a linear relationship between two variables. And so far, we haven't been able to put a number to it, and today we are. So our correlation R, it is a number in between -1 and 1. So take a look at our scatter plot. This red line right here is a regression line, and we're going to be talking about that in the next few days. But I'd like you to see, and it helps when drawing this kind of like a line of best fit, is it helps for you to see that this pattern is pretty linear, and then you want to decide is it a positive or a negative, and clearly this is positive. And students have been struggling with, well, is it weak, is it strong, and what does that look like, and how far away from this line that we would draw would it be strong or would it be weak? And so we're going to continue to look at that, and we're going to look at kind of numbers that would, the correlation numbers between -1 and 1 that match with scatter plots. So I think this is a really great idea for you to pause and kind of draw this out for your own in your notes. If you take a look at the first here, this is negative and it is strong relationship. Now you'll notice that the correlation R is given the value of -0.99, almost -1. So extremely strong correlation. This is a negative, right? -0.67, and this would be a moderately strong or moderate negative correlation. And this is an example of -0.33. This would be an example of a negative weak. So negative, of course, would have that going down. The slope basically is going down, and it has a negative number up in front. So it's 0.33. So this would be a weak negative correlation. This is no correlation whatsoever. We cannot draw a linear line that follows the pattern. This one would be a weak positive at a positive 0.33, pretty weak, not weak, a moderate positive, and then a strong positive at a 0.99. All right, so after today's lesson, I want you to be able to look at a scatter plot and give a number representation of what the correlation is. So let's go ahead and practice 4 together. And while we do this, I'd like you to pause this video. I want you to try this out on your own. I've listed 4 different correlation and numbers, and you are going to match each one of them to the graphs A, B, C, or D. So go ahead and pause this right now and try this out. Okay, so let's see how you did. The first A would be 0.999. Good. Let's think about where's the negative, because I notice there's only one negative there. And so that would be this graph right here. It's going in a pattern is going in a downward. So then you have to decide the other 2. One of them is a more close to 1, so a stronger strength at 0.908. And then one is a little bit more farther away from that line. So I'm going to say that this 0.98 would be C, and this 0.783 would be B. Because if you were to draw a line, you'll notice some of the points are farther away from the line than others. And for C over here, it's either on the line or kind of closer to that line, give or take a few of them. All right, so let's keep practicing. So here is our guessing game. So take a look at this scatter plot and I want you to make a guess. And let's round to the nearest like 1,000th place. So 3 numbers past the decimal and see if you can guess these next ones. So take a look at it. Do you have an idea? Maybe even write it down. And then let's see how you do. Ready? On your mark, get set. Did you get 0.995? Were you close? And if you are, that's good, right? Strong correlation is closer to +1, and that's a pretty strong correlation. Okay, so let's try another one. I'm like pausing to see, like waiting for you to guess it. So then if you're kind of like lost, you should think to yourself, okay, is this linear in terms of I can draw a straight line where most of the pattern, most of the points are kind of the direction it's going in, and something like this. And then you have to determine, well, how far away is the data points from that line? And that's usually very helpful. Okay, you ready? 0.339. Not bad, not bad. Okay, let's do a couple more. Definitely negative, right? Maybe stronger than the last one? Let's see, 1, 2, 3. Negative 0.816. Definitely stronger than the last one for sure. Okay, let's try one more. Do you have an idea? Positive, right? And this one's about 0.507. All right, so don't worry, you're not going to be like looking like on a test question and give me your best guess. It's just a good idea for you to practice so that way when you're able to look at a scatter plot, you're able to determine basically in a roundabout area what the correlation would be. Okay, so let's talk about interpreting correlation, which is really important because there are lots of computers and calculators out there that can give us that number, give us a correlation, but it's what statisticians do with those numbers and it's interpret what they're saying. So let's take a look. So for this problem, the scatter plot shows the relationship between a 40-yard dash and a long jump distance for a particular person. The correlation is negative 0.838. And I'd like you to interpret the value in this context. So we need to write a sentence that represents the correlation and what this scatter plot is telling us. So we're going to say that the correlation of the negative 0.838 indicates that there's a linear relationship between the long jump and the dash time, and it is strong and it is negative. So that's the sentence that I would like you to take some time and write out. And that is how you interpret the context of a problem here. So let's go ahead and do that. So the correlation, and I'm so sorry for my awful handwriting, right? The correlation of, not forward, of negative 0.838, right, indicates that there's a linear relationship between the long jump and the dash time, and it's strong and negative. So for the sake of time, I'm just going to write it as strong and negative. All right, so let's do that again. I'd like you to pause this video and try to interpret the correlation here. This is talking about the number of turnovers and the number of points scored. And this information, this data is from the 2013-2014 NBA season. And it does say that the correlation is 0.92 between turnovers and points. So I'd like you to pause this video and interpret this correlation value. Okay, so you would answer this question. You would say, if I was going to interpret the correlation, I would say that it is the correlation of a 0.92, right, between turnovers and points of the NBA season of 2013-2014 is strong and it is positive. All right. So just because there is a correlation, right, turnovers and points, just because there is a correlation, it doesn't necessarily mean that one causes the other. So I want you to take a look at this graph here. This graph is the age of Miss America and murders by steam, hot vapors, and hot objects. I know this seems kind of weird, but if you take a look at the two, wouldn't you say there's a correlation? I know it's really weird. I know it is. But I mean, look, it definitely shows that it follows that same kind of pattern there. Like we could say, hey, it does correlate with each other. But does that mean the age of Miss America causes murders by steam, hot vapors, and hot objects? No. So this is really important for you to understand that just because there is a correlation does not mean that one causes the other. So correlation does not always mean causation. So let's just take a look at one more weird graph. Per capita cheese consumption, how much of cheese you eat, correlates with the number of people who died by becoming tangled in their bed sheets. I do not make this up, people. I do not. But this is so wild to think about it, right? So clearly there is a correlation that is happening, but we know the more cheese you eat does not cause you to die tangled in your bed sheets. Definitely not. All right, well, I hope you've enjoyed today's lesson. I hope after today that you understand correlation in terms of a number from -1 to 1. I'm hoping that you're able to look at a graph today and you are able to ballpark figure what the correlation would be. Don't worry, we're going to calculate exact in the next lesson. And then I'm hoping also that you can interpret the context of the correlation, or the correlation in the context of the problem, and that you also understand that correlation does not mean causation. So I hope that you guys are having a great day, and I'll see you next time. Bye.